Sorry, I really should take this. Hello, this is Evan's Wizard Repair Shop. How can I help you? Oh, hi, satisfied customer. Oh, unsatisfied customer. What's the problem today? What's the problem every day, I should say? A bug? Oh no, I hate bugs. Oh, I'm so sorry. Okay, walk me through it, and I will take a look at it as soon as I can. And we're in this together. We're gonna squash this bug together. Okay, so you want me to open Wizard? All right, 1 second. Okay, open a document. And then, yeah, raw data view. Yeah, that's where I am. Okay. And you want me to search for a column. Alright. Oh my god, you're right. That's awful. That looks terrible. Yeah, it should move all the columns over to the left. But the ones that remain are just stuck. Oh, that looks so bad. Yeah, you're right. I know. I'm sure that's a big inconvenience with a lot of columns. Yeah, well listen, thanks for the report. Is there anything else? No? Okay. Well, thanks for the report. I'm going to get on it just as soon as I can. And I'll call you back once it's fixed. Okay? So hang on there. Don't lose faith. Oh, thank you. That's very nice of you to say. Uh-huh. Okay, well, I appreciate the report. Call me anytime if you have another one. If you hit any other snags in the program, yeah, I want to know about it. I hate bugs more than anything. Yeah, even more than that. Yeah. Okay, alright, you too. Have a good day. Alright, bye-bye. Oh my god, a customer just found a terrible bug in the program. And I'm going to have to try to fix this. Actually, that was more of a Lifetime movie reenactment I just did. I found this bug last week and fixed it last week. But I wanted to do a new type of YouTube series where I walk you through a bug fix. So I might do some more tutorials of the software later, but today I'm just going to show you how I fix a bug. So if you're interested in software development, Mac software in particular, if you are, maybe if you use the software, if you use Wizard, you use Magic Maps, maybe you'll get something out of seeing how it works under the hood. I'm interested in how things work and showing people how things work, because there's really no magic out in the world. It's all everything works somehow. So I want to kind of demystify some little bits of software and show you how software development works. So kind of fixing a real bug. Out in the real world, affecting real customers. So that'll be the theme today, and hopefully for more videos in this series. So today I'm going to do a video on fixing this particular bug where columns are not properly hidden, or not properly disappearing when you try to hide them in the raw data view. So I'm going to kind of walk you through what this bug looks like, and then show you where it came from and what the fix was, which was, I thought the fix was kind of interesting, and maybe other developers can get something out of it. So I'll go through it. So just to show you this bug again, kind of out of character. If you're in the raw data view, you import some data, you're looking at it, you want to just narrow down this raw data view to a few columns. So if I type in max, I want yield maximum to appear, but I want it to appear over here. It doesn't make any sense with the current behavior of the program. And I think this has only started happening on Mac OS Mojave. I don't remember seeing this bug before. I don't think it's been around forever. But I just upgraded to Mojave last week, so that's when I discovered it and was horrified. Okay, so why does this bug appear? You might be wondering. The best thing to do is to figure out where these columns are being hidden. Okay, so I already know the answer to that. And the way I've got my code base organized is into modules. And so you can see here over on the left, we got the modules folder. We got a raw data module, pivot module, summary module, and you can see these are what the modules are. And then there are a couple more which show up when you do kind of some more advanced multivariate modeling. And Yeah, so we got this file called raw data view controller, and this is the thing that's kind of in charge of all the interface elements you see here. So the raw data view controller updates this checkbox down here. It writes 175 records down here. It kind of manages this edit data button. It's not a gigantic file. I guess it's a few hundred lines of code. But this is sort of where the action is. So this is the controller that's responsible for hiding these columns. And so this is kind of what's screwing up, or at least a piece of the puzzle. So I'm gonna just kind of walk you through the code that's hiding the columns, and then show you maybe why it's not working properly. Okay, so the main action here is in refresh view. I've got like dozens of refresh view functions throughout this code base. Basically, my strategy for updating the interface is when something changes, you call refresh view, and that goes through and makes sure that all the interface elements are configured properly or reflect the internal state of the program. There are other ways to write kind of UI programs or GUIs, but this sort of works well enough. So this is what I do. Okay, so we got this refresh view method or function, whatever you want to call it. And this is where the columns are being hidden. Okay, so I'm going to focus on these few lines of code right here, near the top of refresh view. Okay, so what's going on in this code base? I just kind of want to walk you through the code so you actually understand what the fix is going to look like. Okay, so I'm just going to walk through this code, and then so you understand what's being hidden, and then we'll look at some other stuff and try to figure out why it's not refreshing properly. Okay, so here in this code, we've got a couple things happening. In these two lines, we have a table that we're retrieving its sorted columns here. So the data model here has, you've got a document, and then the document consists of tables, and tables contain columns. So here we've got sheet 1, sheet 2, sheet 3, and sheet 1 contains food group code, NDB, yield description, and a bunch of other stuff. So these are the columns right here, and these are the tables. So we're only going to be looking at one table at a time, or in Wizard you only kind of examine one table, so you can see sheet 1 is highlighted on the left, excuse me. And we get a list of all the columns, so sorted columns, and they're just sort of sorted by their index. We can rearrange them if we want to, like so. So we get a list of the sorted columns, and then we also get a set of the filtered columns. So the filtered columns are whatever appears after we do something like this. Okay, and we got something here. It's a little bit non-obvious, and I'll explain to you. So we're retrieving filtered columns, and I'll show you that definition. That calls columns matching on a string. So column filtered records is a string, and we say, okay, table, give me an array of all the columns that you own that match this string. And in this case, it's like YI. So I can show you real quick. If I put a breakpoint there and type YIE, then we can print out table.column filter records, and lo and behold, we get a bad access. Oh yeah, it's because table's not defined yet. Alright, try that again in just a second. Oh yeah, YIE, right there. So this is what's being called, and then we go back and get the columns matching that string. And originally they're returned as an array, but we convert them into a set using setWithArray. And there's a reason for that. The reason I convert it is that we're going to be testing membership in this array, and membership tests take linear time on arrays, and they take constant time on sets, on set data structures, which usually have some kind of like hash table underneath the hood. So what we're going to do is be testing each column to see if it's one of the filtered columns. And if we didn't do this conversion, then for every column we'd be doing this linear time function, and so it'd be like an order n squared algorithm, which would slow things down a lot. So we had 1,000 columns, and it would take like 1,000,000 different comparisons. If we convert it to a set, then it's a constant time operation. So if we do it for each column, then it's just linear. So if we have 1,000 columns, then it takes roughly 1,000 operations instead of 1,000,000 to do the membership test. So that's sort of the explanation there. And yeah, all right. So we get the filtered column set, we get the sorted columns, and then we are going to test all. We're going to go through all of the UI columns. We have two types of columns in this code base. There are the data columns, or kind of the underlying data structure, and then there are the table columns that are returned from the table itself. So there's the UI table, which is an NS table view, and it has NS table columns. And so that is actually, whoops, I guess I should keep going here. So that's actually this UI element. Okay, so the DS column, that's my data structure that I just made up. That actually stores all this underlying text that's like beef and brisket and chuck and shoulder, or the numbers in the case of this cooking yield, 84, 69, etc. And then the NS column is just the interface element that houses these, okay, and that responds to clicks and what have you. Okay, so we're going to be going through the interface columns here in this code, and we're doing this iteration. So for NS table column in self.records table columns. So we're going to look at each interface element, or each interface column, and we're going to take a look at its identifier. So the identifier, I think, is always a string, and I basically assign an identifier to each of these. I'll show you real quick. Like the identifier on this one is column 1, or column 0, column 1, column 2, column 3, etc. And so I'm going to scan that identifier and then figure out what that index is in the string. So I'm looking at each of these individual NS table columns, and I say, oh, you're column 4. Let me capture that 4, and then look up number 4 in the sorted columns array to actually get the underlying data column. And now we have the hidden test here. So I'm going to set this table column to hidden if one of two things is true. Either this column index is out of bounds, which can happen just the way this code's written. When you're adding and deleting underlying data columns, then the UI columns are also added, but they're not deleted. They're just kind of saved for later. So sometimes you can get something that looks like it's out of bounds. So we ignore that, or we go ahead and hide the table column if there's no underlying data column. And then the other instance in which we hide the NS table column is if this filtered column set does not, so there's a little exclamation point if you can see it, if the filtered column set does not contain this sorted column element. Okay, so we say, here's the UI column, fetch the underlying data column, see if that underlying data column is in this set of filtered columns. And if it's not, then I want you to hide the interface column. Okay, and then we go through all the columns, and voila, that's all we do. So we're hiding the table column, and this should trigger a re-layout of the columns here, but it's not, and I'm going to show you the reason for that. Okay, this is a little bit tricky. So if we go back over here, I told you before that this interface element is an NS table view. I lied a little bit. I have a subclass of NS table view that I use for performance reasons. Okay, I'm going to show you what these are like my proprietary performance optimizations on NS table view. So if you have a ton of columns, then you're probably going to want to write code something like this. So a little pro tip for the Mac devs out there struggling with NS table view. And here is the culprit. Okay, this is what it turned out to be. So we have a function here called auto resize to fit for hiding a table column, and it receives a boolean called is hidden. Okay, so this thing gets called after a table column is hidden. And I discovered this just by profiling the program. Like, you run a profiler and you're like, why is all this time going into auto resize to fit for hiding a table column? Let me override that so it's not taking up all this time. So I'm going to show you briefly. So if I comment this out, so the working hypothesis is that commenting this out fixes the bug. So we'll see if that actually happens. I guess a better thing to do would have been to put a breakpoint there and see if this gets invoked, but I already know the answer, so we'll see it in action here. All right. Do this, and so I'm going to type yield. Oh my goodness, it works. The bug is fixed. Hooray! Yeah, so that fixed the bug. If we just get rid of this little optimization that I made called auto resize to fit for hiding a table column. Okay, so hooray! Let's celebrate. No, the celebration is not in order just yet, and I'll show you why. So I'm going to open a new file, and this is something that has a lot of. Oh no! Oh, I need to buy an in-app purchase to make this work. Oh, this is embarrassing. Okay, well this uses some pro features, so I'm going to run the pro version of the program real quick here. Yeah, so if you want to open DTA files, you need an in-app purchase, which I'm not willing to buy from myself for purposes of this show just yet. So, Wizard Pro opens up the SPSS files and Stata files and SAS files, which I usually prefer to work with because they have better kind of metadata and column descriptions and things. So we'll open this with Wizard Pro. Opens like a boss. Here we go. Is that going to work with us? Yeah. Okay, so here is another file which has a lot more columns. So this has 1,109 columns. Okay, so we're working with a lot here, and I'm just going to show you what happens when I try to filter. So here's a column called family 16. I'm just going to type in family, oh, and the interface freezes. I get this beach ball, which is not. So if I take that away, the behavior is correct, but I get a beach ball. It's not filtering very quickly, and I can show you the reason for that, and which I will do. Let's see. Open Developer Tools, Instruments. Not musical instruments, sadly. But if I run a little profiler on Wizard Pro, watch what happens. I'm gonna hit the record button. This is a great tool, by the way. I use instruments all the time. Like, if you're confused or kind of want to know why Wizard's really fast, it's because I use instruments all the time. Like, anytime the sound is just a tiny bit too slow, I bust out instruments and start kind of hacking away at the code to speed things up. Okay, so I'm going to check this little button called Invert Call Tree, which y'all explain in a second. And then I'm going to go back to Wizard Pro, type in yield. I meant to type in family, but you see the beach ball here. So it's taken forever to figure out which columns to actually show. And if we go to instruments, look at all that blue. All right, we got a blue wave right here. And so I'm going to stop the profiler, and you can see this spinning. So that's the beach ball that we saw. And if I click main thread, it's spending all this time in convert point to superview. Okay, and you might think, well, what's calling that? So that's what invert call tree does, is it shows you like the bottommost function that's taking up time rather than the topmost. So if I did the topmost, it'd be like main thread, ns application main, and then I'd have to like click through a ton of stuff. This way I kind of work backwards and figure out what's using all the CPU time, figure out what calls that, and then kind of go through here until I see some of my own code or see something that looks familiar. So I'm going down through here. It might be difficult for you to read it, but we're calling this min table width at some point. There we go. There's the old culprit. All right. So here's my code. DS raw data view controller refresh view. That's the one I showed you at the very beginning. That calls set hidden. Okay, so we saw that already. Go back here, and so here's set hidden that's being called. And then set hidden, so inside that, and we can't see it because OS X is all proprietary, but we can kind of figure out what's going on just from the function signatures. That's calling a function called auto resize to fit for hiding a table column. Okay, so that's exactly what I feared. That I commented this out, or if zeroed it out, and as a result, the function in the super view, or not the super view, but the parent, whatever, object class, has an implementation of this that's really slow. Okay, so basically what is happening is we're iterating through all these columns, okay? And each time we hide a column, it relays out all the other columns. Okay, so that it ends up being this really expensive process. Remember, we have 1,000 columns in this file. So for each of those 1,000 columns, we hide it, and then it says, "Oh, you hid it. Let me relay out everything, all 1,000 of the other columns." So 1,000 times we're laying out 1,000 columns. That's like 1,000,000 layouts that we're doing, and that's why we get the beach ball. It's an n squared algorithm. So that's the source of all the pain and suffering and slowness in this code, is that n squared bit. So the solution that I came up with, I'm not thrilled with. It's just kind of something I have to do because I don't have the source code to NS table view. But I go ahead and put this code back in. So I put the override back in, the auto resize to fit. And that's supposed to be calling like min table width at some point and caching table column positions and all this jazz. So I'm going to put this override back in and say, okay, when you hide a table column, don't relay out the whole thing. Instead, what I'm going to do, this is a little bit horrible. I'm not very proud of this code, but I'm going to write it anyway. But when we're going to go through and we're going to hide all the columns that we want, since that in itself is very fast. It's kind of that layout that takes forever. So I'm going to go through, hide everything, and then sort of force a layout at the end. Okay, so I'm going to say first NS integer first column width, and the very first column in this table is always this index. So let's see. Yeah, so I'm going to say self.records table. I guess I could do, I want column with identifier. I guess I could do column with identifier. No, I'm just going to do table columns dot first object dot width. Okay, basically I'm just going to jigger the very first column in the table. So it's not it's not the thing with identifier column 0, which corresponds with data column. It's this kind of this special index column that I'm just going to kind of push and then pull back to sort of force everything else to be laid out again. Again, I am not proud of this code. I'm proud that it fixes the bug, but this is sort of dirty code that I'm forced to resort to just because NS table view kind of sucks. Okay, so here's what we're doing. We're gonna say self.records table columns first object width equals first column width plus 1. So I'm just gonna push it just a little bit, just make it a little bit bigger, and then I am going to push it back to what it was originally. Okay. So this is kind of horrible code. It's a total hack, and that's the way a lot of this works. There's just not always a good way around it. I could maybe try to do something more clever, but this is the only place where the columns are hidden kind of en masse. So doing this little hack is fine. And so I'm going to say here, add a little note, hack to deal with Mojave. Yeah. We'll just say hack to deal with Mojave. Which just tells me if I change this code, make sure it works on Mojave later. So, yeah, let's give it the old college try here. So I'm going to restart the program. It's building, going through all those amazing tasks. Yeah, so this is started using Xcode 10 recently in order to build on Mojave, and yeah, it's pretty good. Some of the syntax highlighting seems a bit slower, but overall, Xcode's it's a lot more stable than it used to be. I'll tell you that. All right. Anyway, enough color commentary. That's not what you came here for. Okay, so now I'm gonna reopen 2000.dta. And see what do it look like. All right, all 1,109 columns. I'm going to search for fam. Oh, and it filtered down. Family. Yeah, all right, look how fast that is, too. So I can just type anything. Like type form, and it just, boom. Type info, boom. So it's not beach balling anymore. So that's the main thing I was worried about, because the only thing I hate more than bugs are beach balls, or well, the digital kind. And yeah, so as a kind of a last test, I'm going to open that other file, the old poultry USDA data. No, the beef. Yeah, beef data. Type in yield, and hooray! It's fixed and it's fast. So that is the entirety of the bug fix. I think maybe I did something slightly different because it's showing me that there's a git diff. So it's not like exactly what I did to fix it, but it's extremely close. So yeah, that's it. That is the fix to the case of the missing columns, and it is now available in Wizard 1.9.24, available in the App Store near you. Okay, so that's all I had to show you. I think this is a pretty representative bug of just kind of what it takes to fix an interface issue or other issue in the software. You might be, if you're a professional software developer, you might be saying, "Whoa, where's the automated test?" I don't have tests for most of the interface code, just because it's a real pain to do, and if you really get good coverage, then it takes forever to run. All the numerical code is very well tested, and I have a large test suites for those. But for this stuff, I just kind of wing it, and that's served me well so far. So there's your answer to that. Testing UIs is very difficult. So my hat's off to you if you figured out how to do it in your own UI, or maybe you have some tips to share with me if you have good strategies for testing things like this. But yeah, that's the end of the episode. Hope you enjoyed this. If you have any bugs to report in the software, maybe I'll make it the subject of a future video. In the meantime, check out the channel, I guess. I don't know. I'll have a good send-off message sometime in the future. But I hope you enjoyed it. Leave a comment and hit the subscribe button. Take care.